Zwitterion. Zwitterion are molecules with a positive charge on one atom and a negative charge on another atom in the same molecule, dipolar ion. The molecule has no net charge. Okay, look at the example. This is a neutral form of amino acid. Okay, when the protons transfer, so it will become Zwitterion, which is, that's mean, the proton in the carboxyl group will be transferred to the amino group to form COO negative as the carboxylate ion, and the other part will be ammonium ion NH3+. This salt, Zwitterion, is the neutral form of amino acid. Okay, look at the example, glycine. When the glycine form, the proton transfer, that means one hydrogen will transfer to the amino group. So it will be ammonium cation, NH3+, and carboxylate ion, C double bond O negative. Amino acid exists as the Zwitterion in solid state and neutral solution. The dipolar nature of amino acid gives them unusual property such as a very high melting point, high solubility in water, low solubility in organic solvent such as ethanol and ethoxyethane. Since amino acid exists as Zwitterion, they are too polar to be soluble in organic solvent like diethyl ether. Zwitterion is amphoteric. Okay, what is the meaning of amphoteric? You look at the sentence. It acts as a base in the presence of an acid, and it acts as an acid in the presence of base. In acidic solution, a Zwitterion accepts proton to yield a cation. Okay, the carboxylate ion will receive one hydrogen ion to form C double bond OH, and the byproduct is water. A Zwitterion acts as a base as a proton acceptor. In a basic solution, a Zwitterion loses a proton to form an ion. That means one of the hydrogen ion from the ammonium ion will be donated to the hydroxyl ion to form water and NH2. A Zwitterion acts as acid as a proton donor. This means if you decrease the pH by adding the acid to a solution of amino group, the COO negative part of the Zwitterion pick up a hydrogen ion. So look at this example. Okay, the COO negative will receive one hydrogen ion to form COOH. So notice that this is now a positive ion, no longer Zwitterion. And if you increase the pH of solution of an amino acid by adding hydroxide ion, the hydrogen ion is removed from the NH3+ group. Okay, look at the ammonium ion here. We donate one hydrogen ion to hydroxyl group to form water, and notice that this is now a negative ion, no longer Zwitterion. Zwitterion, the equilibrium between Zwitterion, ionic and cationic form of acid amino. So Zwitterion in the cationic form predominant in acidic solution. Anionic form predominant in the basic solution. In low pH, it will be in acidic medium protonation, and in the high pH, the basic medium, it will be deprotonation. Isoelectronic point, PL, the pH at which the amino acid exists primarily in its neutral form, no net charge, is called isoelectronic point. At PL, Zwitterion is at its maximum. The concentration of anion equal to the concentration of cation. The net charge equal to 0. Okay, look at the example. The PL for glycine is 6.1. Okay, at 6.1 pH, at pH below than 6.1, okay, the compound will be positively charged. At the pH more than 6.1, okay, the compound will be negatively charged. At pH below than 6.1, the average charge of glycine is positive. At pH more than 6.1, the molecule become negatively charged. And at pH equal to 6.1, the equilibrium contain the concentration of cation equal to the concentration of anion. Zwitterion have the maximum concentration. Okay, we will proceed our lecture with the new subtopic 12.2, chemical properties of amino acid. Okay, look at the learning outcome. At the end of the lesson, students should be able to describe the formation of peptide bond in dipeptides. Formation of peptide bonds in dipeptide. When two amino acids react together, a water molecule is eliminated. That means H2O will be eliminated and dipeptide is formed. This is the condensation process. Okay, look at the example. Look at the example. Both compounds are alanine. So what happened? Okay, the hydroxyl ion from the carboxylic group, okay, will be eliminated, and hydrogen atom, okay, from the amino group will be removed to form water molecule. And okay, the bonding between C double bond O and N is formed. This bonding called as peptide bond, and the new compound form, which is the peptide in the bracket amide. Take notes here. Each amino acid unit in peptides are called amino acid residue. Okay, look at the second example. Okay, when two different types of amino acid react together, two different combinations are possible depending on which amine group react with the which acid group. Okay, look at the example. Okay, alanine and cysteine. Okay, what happened? Okay, so the hydroxy group from the alanine will be eliminated, and the hydrogen from the amino group from the cysteine will be eliminated to form byproduct water, and the new compound form, which is ALA-CYS form. This is dipeptide. Okay, with a different compound. Okay, so look at the next example. Okay, we have cysteine and alanine. Okay, the H2O will be eliminated and become the byproduct, and new bond form, peptide bond form, and the new substance is cis-ALE. Okay, look at the last example. Okay, write a reaction between phenylalanine, okay, this is a phenylalanine, and glycine to produce PHEGLY. Okay, try to find out the answer. Okay, I'll give you 2 minutes to complete this task. Okay, have you done? Okay, let's check your answer. Okay, we have phenylalanine and glycine. Okay, and the answer is, ta-da! This is the answer. I hope you enjoyed the video, and that's all for today. Thank you.